Okay, lesson 6 is the continuation from lesson 5. So it starts off again with that review that we looked at from the last lesson. The thing to remember is your factor is always the reciprocal of the replacement. So if I replace x with a b times x, my factor is a 1 over b. They always show the replacement of y with a 1 over a, because then when you bring it over, it becomes a times y. Just remember, if you replace y with an a times y, the factor is 1 over a. If I make those a or b values negative, I have a reflection that happens as well as a stretch. So if we jump into the first class example, it says write the equation image of y equals x squared after a horizontal stretch about the y-axis by a factor of 3/4. So if I have a horizontal stretch, what is my replacement? X with a 4/3 x. Horizontal means I'm replacing my x. My factor is 3/4, so my replacement is the reciprocal. So in my equation, y equals x squared, I would now have y equals 4/3 x squared. And then if I took the extra step and I actually calculated what is 4/3 squared, what do I get? 16 ninths. So I have 16 ninths x squared. Okay, so if we look at b, b is y equals the square root of x minus 3. I have a horizontal stretch by a factor of 4 about the y-axis and a vertical stretch by a factor of 2 about the x-axis. So horizontal stretch by a factor of 4. What's my replacement?
X is replaced with 4x.
Is it 4x? 1 over 4. It's always the reciprocal of that factor. Okay, vertical stretch by a factor of 2. What's my replacement? So then in my equation, y equals the square root of x minus 3, I would now have 1/2 y equals the square root of 1/4 x minus 3. And I want to write this as a y equals equation. So how do I get rid of the 1/2? What operation eliminates the 1/2? Multiply by 2. So if I multiply this side by 2, I multiply the other side by 2. Look at what's underneath the radical. Can I simplify the square root of 1/4? Can I take its square root? So can I take the square root of 1? Can I take the square root of 4? So what's the square root of 1/4? 1/2. So I get y equals 2 times 1/2 times the square root of, or sorry, this should all be multiplied by 2. Like that. So what's 2 times 1/2? 1. So I'm left with root x. And 2 times negative 3? Negative 6. And c is the equation y equals 3x plus 7. I have vertical stretch about the x-axis by a factor of 1/3 and a reflection in the x-axis. What is my replacement? So look at the vertical stretch first. What's my replacement on the vertical stretch? reflection in the x-axis. So what's my replacement on the reflection?
Y over negative y.
And then when I put them together, I would get a negative 3y. So what does my new equation look like? Instead of y equals 3x plus 7, what would I have? So negative 3y equals 3x plus 7. I want the y by itself, so what do I divide everything by? Negative 3. So I get 3x divided by negative 3 and 7 divided by negative 3. So 3 divided by negative 3 is negative 1, so I get negative 1x or just negative x. And then my 7 divided by negative 3 would become negative 7/3. Okay. Class example number 2 works the other way. They give you the two functions and they ask you how the second one compares to the first. We're still going to use replacements. So if my original function is y equals f of x, and my new function is y equals f of 1/2 x, what was my replacement? What did I change?
X with 1/2 x.
And if I replace x with a 1/2 x, what will I have?
Horizontal stretch by factor 2.
Yes.
Of the y-axis.
What's my replacement on b? What did I replace?
X with 3x.
And if I replace x with a 3x, what am I doing to the graph?
Horizontal stretch by factor 1/3.
Yes. Okay, so I want you to do the next 4 on your own. I'll give you a couple of minutes. Okay, let's look at C. What's my replacement on C?
Y with negative half.
Why is it negative 1/2?
Because you need to use the reciprocal.
Well, because originally, first of all, this negative 2, is it with the x or is it with the y? It's with the y, because if it was in the x, it would be in the absolute value, it would be inside those bars. So if I bring it back to the other side, there's my negative 1/2. So think, where should it have been to begin with? If it was with the y, put it over back with the y so that you can see that replacement. Now that I have my replacement, it's a y, so I know it's a vertical. And it's a multiplying, so it's a vertical stretch. My factor is 2. What does the negative tell me?
Reflection.
I have a reflection. And what kind of reflection? Which axis do I reflect in? The x-axis. And if you're having trouble remembering if it's the x-axis or the y-axis, sketch it out. If I'm doing reflection of my y coordinates, and I go from a positive y to a negative y, which axis did I cross? I crossed the x-axis. Okay? If I look at D, I have y equals x cubed and 3y equals x cubed. What's my replacement?
Y with 3.
So like the last question, what kind of a stretch do I have?
Vertical stretch.
And what's my factor?
1/3.
Say that again?
1/3.
1/3. And I'm skipping the about the x-axis tiring writing it out all the time. Okay, look at E. I have y equals the absolute value of x, and then my other equation is y equals 2 times the absolute value of 1/3 x. How many replacements do I have? 2 replacements. What are they?
Y is replaced with the 1/2 y. And x is replaced with the 1/3 x.
Yes. Oh, I did that backwards. Okay, y with a 1/2 y, and x with a 1/3 x. And why is this a 1/2?
Because it needs to go on the other side.
Because the 2 needed to go back to the other side to be with the y. So what are my stretches? Vertical stretch, factor of what? 2. Horizontal stretch, factor 3. So again, if I'm looking at my replacements to my factors, they're reciprocals. Look to the replacements, not to the equation, because the equation is going to screw you up. Because you're going to look at the equation and you say, well, the factor is the same here, but it's different there, and I can't figure it out. Go to the replacement. It's a common mistake. It's not an isolated where, oh, one person can't figure it out. It's, I'm not picking on you. I feel like you think I am. I'm not. Because this happens every year. I've taught this for like 15 years. Well, maybe not that long. Close. But it happens every single time. And again, it's just because of the way that our brain works. We like things to match. How come the 2's match here and the 3's, they match this way? The pattern goes from here. Go to the replacements. Okay, so if I look at F, y equals the absolute value of x and y equals the absolute value of negative 2x. What's my replacement?
X is negative 2x.
So I have an x value, which gives me a horizontal stretch. What's my factor? 1/2. What about that negative?
It's a reflection of the x.
So this 2x, if I wanted to, I could break it up into a replace x with a 2x and replace x with a negative x. Because my factor is always going to be a whole or a positive number. Okay? I don't have a stretch factor by negative 2/3. It's positive 2/3 and then the reflection.
So it doesn't make a difference if it's in like an absolute value because it's a negative, so
No. Class example number 3, the function represented by the thick line is a stretch of the thin line. Write an equation for each function represented. So these ones are a little bit trickier. We have to look at our coordinates. Which coordinates look like they're changing, the x's or the y's? The y coordinates. If I look at a y coordinate here, I have a 6, and it went to a 3. What can I multiply by 6 to get to 3? 1/2. That is my stretch factor. So if my stretch factor is 1/2, and it's vertical, what is my replacement? What did I replace y with? 2y. So then my equation would be 2y equals 6 over x squared plus 1. How do I bring the 2y to the right-hand side of the equation?
Or divided by 2.
Divided by 2, or the same as multiplied by 1/2. So y equals 1/2 times 6 over x squared plus 1. over x squared plus 1. If I put those two functions into my calculator, those are the two graphs that I would get. So if I look at b, what seems to be happening in this function?
Is there a reflection in both?
I don't know. Is there a reflection both? Yeah, because if I look at this part of the graph, if I was to flip that, that's where I would flip to go this way. And then if I flipped it left, right, wait a minute, that didn't flip the way that I wanted it to. Yeah. Yeah, so now it's actually going the same way as the original question. So I had a reflection in the x-axis. I had a reflection in the y-axis as well. Now, what seemed to move? My y-coordinates or my x-coordinates? And this one this one's a little bit trickier. So if I erase this green one, then that's messing us up. I look at some of my anchor points. If I take this and I reflect it across here, it moves to that point. It's not going to impact when I do the reflection along the y. So it went from 3 to what? So it went from -3 to -6. What's that a factor of? 2. So that's a vertical stretch factor 2. The reason why it's vertical and not horizontal is if I take this point right here, if I move it to here, and then I move it to here, it actually matched up. So that x value matched up. It can't be a vertical, or sorry, it can't be a horizontal because my x values are still matching when I undergo the transformation. If I take this one, so look, if I reflect this down 4 to 4, and then I reflect it this way, so it gets reflected another 4. Oh, sorry, it's this one. So it goes up, and then it reflects over. It's not moving, it ends up. Sorry, I have to start from the thin line. I'll start that over again. This was my thin point right here. So if I reflect it up, and then I reflect it over, why is it not matching? It should be matching. It's not. I lied. Oh no, sorry, it is matching.
Yeah, to the top, yeah.
It's matching to this one. It's a Monday. So my x values are matching up, my y values aren't. It helps the teacher didn't it so much. If I reflect in the x-axis, what's my replacement? If I replace in the x or y-axis, what's my replacement?
X with a negative x.
And if I I do a vertical stretch by a factor of 2, I replace y with what?
1/2.
So then my equation becomes, I can combine my negative y and my 1/2 to get negative 1/2 y equals f of negative x. If I move that negative 1/2 over, I would multiply it by negative 2. So I would get negative 2 f of negative x. And the two negatives would not cancel each other out. Because one's inside and one's outside. Okay, so if I look at C, is there a reflection in C? No. Do I have a vertical or a horizontal stretch? Horizontal? Are you telling me or are you guessing?
No, I'm telling you.
You're telling me?
Yes.
I like the authority in your voice when you're telling me. Okay, so I have a horizontal stretch. What's my factor? So look at my x-intercepts. What am I stretching them by?
2.
Factor of 2. So horizontal stretch tells me I'm replacing x. What am I replacing x with?
1/2 x.
A 1/2 x. So then my equation becomes 1/2 x plus 4 times 1/2 x minus 2 times 1/2 x minus 6. We don't leave equations with these fractions in them. Whenever we write an equation in factors, our coefficients should always be whole numbers. So if I pulled this 1/2 out, if I divided 1/2 x by 1/2, what's 4 divided by 1/2? 8. So I pull out the 1/2, and I get x plus 8. If I pull out the 1/2 from the second factor, what would I be left with?
X minus 4.
And if I pull out the 1/2 from the last factor, I would have x minus 12. All of these factors are being multiplied together. So if I multiply the 1/2 and the 1/2 and the 1/2, what do I get? One times 1 times 1?
1/6.
Not 1/6. 2 times 2 is
4.
times 2, 8. So 1/8, and then x plus 8, x minus 4 times x minus 12. And that would be all in one line. Okay, last question. Polynomial function has the equation p of x equals x minus 4 times x plus 3 times x minus plus 6. Determine the zeros and the y-intercept if the following transformations are applied. So let's look at the original function to begin with. What are the zeros of p of x? So what are the zeros of this function?
4, negative 3, and negative 6.
Yes. Okay. What's the y-intercept? How do I find the y-intercept? Make x equals 0. So I have negative 4 times 3, which is, times 6 is, so the y-intercept would be negative 72. That's my original. So let's look at A. Y equals negative 3 times p of x. What's my replacement? what am I doing to the equation? Vertical stretch by a factor of 3. Is that all I'm doing?
Reflecting it in the x-axis.
If I do a reflection in the x-axis and I do a vertical stretch, which coordinates am I impacting? The x's or the y's? They're both y ones. Because when I stretch over the x-axis, I'm changing my y coordinates. So is this going to change my zeros? No, because my zeros are x values. And my zeros are on the y-axis. They're on the x-axis, which means my y value was 0. When I stretch it by a factor of 3, still stays 0. When I reflect it, still stays 0. So no change in the zeros. They will stay at -4, 3, and 6. 4 and -3 and -6.
What?
The y-intercept, what will happen to the y-intercept?
It'd be reflected.
Okay, so it's at -72. So if I reflect it, what will it become? Positive 72. And then if I stretch it, and how do I get the 216?
72 times 3.
Multiplied it by the factor. Okay. So let's look at B. I have y equals p of -1/2 x. What's my replacement? What did I replace x with?
-1/2 x.
And what does that tell me to do to the graph?
Reflect it.
In which axis?
Y-axis.
Okay. And what else?
Factor of 2.
Okay, what's the factor of 2?
Horizontal.
Horizontal stretch. Okay? So horizontal stretch by a factor of 2. Which coordinates does that impact? The x's. So is that going to involve my zeros?
Yeah.
Yeah. So my zeros. I had 4. When I reflect it, it's going to become, it was positive.
Oh, maybe.
It's going to become negative. And then when I stretch it, it will become -8. Then I have -3. When I reflect it, it will become
3.
And when I stretch it, it will become
6.
And -6. When I reflect it, will become
6.
And when I stretch it, so there are my new zeros. What about my y-intercept? Stays the same. Because the coordinates of my y-intercept are 0 and -72. When I reflect 0, it stays at 0, and when I multiply it by the factor, it still stays at 0. What happens if I stretch this first? The 4 would then become, and then when I reflect it, it would become, so it didn't matter which way I did it. Okay, your questions. 1 ADH, 2 AC, 3 BCG, 4 C and D